Hello friends, today we are discussing the equation of continuity and energy processed by a liquid. Consider a horizontal pipe with a different shapes. A liquid is flowing through the pipe. The flow of liquid is assumed to be a streamline. Consider a small area A1 at P perpendicular to the direction of steady flow of a liquid and draw a streamlines through the boundary of A1 so that the tube PQ is obtained. This is known as a tube flow, a tube of flow. Since the side of such tube are everywhere in the direction of flow of the liquid, no liquid crosses the sides. Actually, the liquid moves inside a tube of flow just as if the tube has solid walls. We assume that the liquid under consideration is perfectly mobile and incompressible. The same amount of liquid flows across every section of the tube in a given time. That is, the volume of liquid passing through area A1 is equal to that passing through the area A2. Here the velocity of flow at P is V1. The velocity at point Q is V2. The volume of liquid entering per second, or we can say that is the rate of flow at P. Volume of the liquid entering per second or rate of flow at P is equal to, what is it? A1 V1. What is the A1 V1? If the velocity of the liquid across the area A be V1, then obviously the liquid crossing A will move forward a distance V inside the tube in 1 second. Thus the volume of the liquid crossing the area A in 1 second will be equal to the volume of the cylinder of cross-sectional area A and length V. So the rate of flow of the liquid through A is AV. And the volume of the liquid living per second at Q, that is A2 V2. Sorry, by mistake here I am writing the P. It is not the P, it is a Q, and A2 V2. So volume of the entering and volume of the living liquid of the living entering point and the living point. So if we know the densities, that is the rho 1 and rho 2 are the densities of the liquid at two sections, then the mass of the liquid entering per second at P is A1 V1 rho 1, and the mass of the liquid living per second at Q, that is A2 V2 rho 2. If there are no sources or sinks within the volume of the liquid between the sections P and Q, then the mass of liquid crossing the areas A1 and A2 per second must be the same, and that is A1 V1 rho 1 is equal to A2 V2 rho 2. As the liquid is incompressible, therefore the densities of entering and leaving side liquid is same. So that is the rho 1 is equal to rho 2. Thus we get A1 V1 is equal to A2 V2. Thus the volume of the liquid entering the section P is equal to the leaving the section Q. This equation is known as equation of continuity. For the steady flow of a perfectly mobile and incompressible liquid, this means that where the cross section of the tube is small, the velocity is greater, and vice versa. This explains why water at a place where it is deep appears to be a still. So this is the continuity of equation. Suppose when you are gardening to the garden, watering to the garden, in that case, when the tap is open, water tap is open, the flow of liquid through the pipe remains constant, although that pipe is in curve form, because the diameter of the pipe is same throughout the section. So in that case, the water is streamline flow and the velocity of the liquid is constant throughout the cross section because the liquid is incompressible. At the entering side of the close to the tap of water tap and at the leaving side, the velocity remains constant. If we are taking the 1-inch pipe and connecting to the 2-inch pipe, so at the entering or what we say the leaving of the 1-inch pipe, that is the entering at the 2-inch pipe, is changing their velocity. Here the velocity is changed, but throughout the 2-inch pipe the velocity and cross section of the area remains constant. So this equation is continuity of equation. Now energy possessed by liquid, how it is possessed? A liquid in motion possesses 3 forms of energies. First is the pressure energy, then kinetic energy, and third one is the potential energy. For that purpose, here we are taking a tank with a base at the upper surface of the water level. Then at the center where the connector is connected, the piston is there, so that the tapping, or we can say simple tap is there. So if the tap is open, the water start to flow from this pipe. So this is the piston. So this level where the water is entering through this cross section of the pipe through the piston. When the piston is open, so the water start to flow this. So remaining level is here, this one. So this is C and D. This height is referred as a H. Now when the tap is closed, the piston is closed, so the pressure energy is here. If the water level is high inside the tank, then we get the pressure, but the water height is less, then the pressure is minimum. So let an incompressible liquid of density rho be contained in this tank, provided with side tube, this tube that is referred as a T, at a depth H. This is the depth of water below the free surface AB of the liquid in the tank. At the level CD, so this is the axis of the tube, this tube. There is a certain pressure, यहाँ पे कुछ ना कुछ तो प्रेशर होता है. वो प्रेशर क्या होता है? The density of the water or liquid, whatever it may be, then acceleration due to the gravity, and H. So here this certain pressure P is equal to rho GH. If more liquid is to be introduced into the tank at this pressure, it must be forced in by the piston. यहाँ पे जितना हम पानी बढ़ाते जाएंगे इस टैंक में, इतना प्रेशर इस पिस्टन के ऊपर प्रेशर आता जाएगा. If alpha be the cross sectional area of the piston, then the force on the piston is the P into the cross sectional area of the piston, that is the alpha. Now move the piston inward direction. Then what action takes place? Suppose हमने क्या किया, इस पिस्टन को अंदर की तरफ पुश किया है विथ स्मॉल डिस्टेंस x के हिसाब से, यहां से यहां तक हमने थोड़ा पुश किया है अंदर, तो क्या होगा? A volume of cross sectional area of the piston into the displacement of the piston x. This is the product. So Ax, or how much amount of mass of liquid is pushed inside the tank, that is the mass into proper cross sectional area into x into rho of the liquid is a force into the tank, and the amount of work done is doing. So work, when the piston is moving inside, the work is done. So that work is W is equal to PAX. The work becomes the pressure of energy of the mass, that is the AXP, or not A, that is the cross sectional area of the piston, that is the alpha x rho of the liquid in the tank, because it is capable of performing the same amount of work done in pushing piston back. मतलब हम जितना इसको अंदर पुश करना चाहेंगे तो उतना प्रेशर टैंक की तरफ से, मतलब पानी का प्रेशर आएगा. देखो आप एक काम कीजिए, एक खुला पाइप, मतलब विदाउट टैप का, आप उस प्रेशर को हाथ लगा के लगाइए. जितना आप प्रेशर अप्लाई करेंगे उतना ही आपको अंदर का पानी आपको प्रेशर से आपके पाम के तरफ फोर्स करेगा. सो उतना ही वर्क वहां पे भी होगा जितना आप इधर से वर्क लगाते हो. When we are escaping from the tank, what action takes place? The amount of work is done pushing the piston back. So thus the pressure energy per unit mass of the liquid is P by rho. So P alpha into x divided by alpha x into rho. Since alpha P and x is the pressure energy of alpha x volume, the pressure energy of per unit volume of the liquid is P alpha x divided by alpha x. So alpha x and alpha x get cancelled, so we get the P. So this is the P is the pressure energy of the liquid in the tank. Another energy is that the kinetic energy. The liquid has inertia and therefore it possesses kinetic energy when in motion. मतलब अब टैंक के अंदर जब तक है तब तक उसकी पोटेंशियल एनर्जी होगा, और जैसा पिस्टन मूव हो जाएगा आप इनसाइड और आउटसाइड द फ्लो ऑफ वाटर आल्सो बी चेंज. सो when the flow of liquid is in motion, the kinetic energy possesses. Thus, if a mass of m of the liquid is flowing with velocity v, its kinetic energy will be half mv square. Hence, the kinetic energy per unit mass is equal to half v square, and kinetic energy per unit volume is half rho v square. Then the potential energy. The liquid possesses the potential energy by the virtue of its position. Thus, if mass m situated at the mean height h above some reference horizontal level, its potential energy will be mgh. Hence, the potential energy per unit mass is gh, and potential energy per unit volume is rho gh. With the help of the continuity of equation and energy possessed by liquid, Bernoulli's gives the theorem that states that the total energy of small amount of an incompressible liquid flowing from one point to another point without friction remains constant throughout the displacement. जैसा कि हमारे यहाँ हम देखते हैं कि फाउंटेन्स, अब उस फाउंटेन्स के ऊपर हम बॉल रख देते हैं छोटा स्मॉल वेट का, एंड with the help of the pressure energy of the liquid flow, the ball is in top of the fountain. So it maintains every time, because if the any pressure energy is changed, the ball is fall on the pond. So but whenever there is a pressure, the ball is on the surface of water at a particular height. So it gives the Bernoulli's theorem. So at every time it remains constant. So then we can say that the pressure energy plus kinetic energy plus potential energy is equal to constant. So this is the Bernoulli's theorem. Later on we discuss in the next section. I hope you understand the continuity of equation and energy possessed by liquid. Thank you very much for the watching the video. Thank you.